So now lead to the next questions, how essential is the temperature for the successful isolations, and what temperature is ideal? Temperature is extremely critical for successful isolations. I think during the isolation, as well as the functional measurements, it's critical to really ensure the physiological temperature of 37 degrees is really kept. I think this is because in this condition, heart actually operates the most properly. And so then this way you can really get the myocytes out. And then once you get out, the myocyte, you can keep it into the room temperature. If you're going to using the myocyte same day for your functional measurements. And otherwise, like we just talked about earlier, if you want to give them a little bit treatment, require sometimes, then you need to keep it into the proper culture conditions. So I think this is pretty much straightforward, and unless Matt and Devor has something to add on, I may move on.
Actually, this is very interesting to me because certainly in our injection method, 37 is certainly the temperature at which the digestion will proceed the fastest. And I would always recommend that if possible, people do keep things at 37. But I have done isolations at room temperature as well, and it took longer. The yield is slightly lower, but I still got good myocytes. And so this how critical temperature is an interesting thing, which seems to differ between the two techniques, and I'm not sure why that is. I don't know if you have any insight on why that might be, actually. Have you ever tried to isolate myocytes at lower temperatures, and you have a poor yield, or do you have a good yield but the myocytes are less functional?
Be all honesty, we actually, only if it's only like when the system is broke down, the temperature circulating system
right.
broke down. So in that conditions, generally we did not get the good cell out of it. And so, but that's anecdotal. So if we are not into those fail of the system and just control system temperature to drop them lower, I actually could not answer that. But right now you mentioned that we're actually eager to try.
Yeah, let us know.
Run the test. So stay tuned. We may get back to you guys for a different answer. Right now, I think 37 is based on our experience. But hey, maybe something new. You never know.
Certainly, many protocols would certainly agree with you. I think most, actually. So yeah, I'm not sure either, but it'll be very interesting if you do give that a try.
Now I'm curious. I would definitely give that a try.
So there you go.
Sorry, do you have anything as well?
No. I'm just going to say that which student, I wonder, in Ronglih's lab is going to do the project. No, I mean, I would just say that all the isolations that we do in Birmingham, at least, are done, and when I was at King's as well, were done always at 37 degrees. Some of the functional experiments weren't always done at 37 degrees. Although obviously it's always recommended to do so, but sometimes, for example, some of the calcium transient experiments we didn't always do at 37 degrees, even though, of course, I understand that that's sometimes therefore not physiological. But isolation-wise, we always use 37. So just like Ronglih, I've never, in my labs at least, never tried it. So it'll be interesting.
Yeah, for one of your fellow try to.
maybe.
Davor, so, coming back to that point, certainly some people do some contractility and calcium experiments at room temperature on the Inoptic system, and I think we've done that as well.
Yes. Yeah.
And for other purposes, I think for electrophysiology, sometimes you lower that slightly to 35 degrees. Now you're the expert more in this than me. I wonder if so I'm going to put you on the spot. What's the reason for that? Is there any particular reason?
So, for example, if you're doing sodium measurements, sodium current that you measure, sodium currents that you're measuring using patch clamp, then I suspect that the influence of the temperature is not as great. So, therefore, you'll see that a lot of sodium measurements are done at room temperature. If you're doing sodium potassium pump measurements, of course, then that's an ATPase, and that's highly sensitive to temperature. So the function of the sodium potassium pump would then obviously be incredibly responsive to changes in temperature. So therefore, whenever we did sodium pump measurements, we would always make sure that we're working at 37 degrees. For the calcium transient experiments, so the ion optics experiments, the reason why I sometimes used it, even though many people have told me off, I'll be honest, is because it was easier to do the experiments. When you're trying to do calcium transient and contractility experiments in isolated cardiomyocytes at 37 degrees, it's not always the easiest methodology to employ and the easiest system to work with. So it was the ease of use, but we're obviously always aware of the caveats of that as well. So hopefully that answers your question
Right.
as much as possible.
I have one more thing on this slide to put. I think Davor and I have discussed this, but I might put this to you as well, Ronglih. So there will be a time between isolating your myocytes and actually doing a functional measurement. And on your slide, that can be up to 4 to 6 hours. Now, you keep the cells at room temperature during this time. And we do the same. But some people would keep them on ice during this time. And some people would argue they should be kept at 37 degrees during this time. I wonder if you've actually tested either of these different ways of doing it. And is there a reason why room temperature is the best while the cells are there waiting to be functionally analyzed?
So I cannot direct answer your question, but this actually raised an interesting point. And I think for any viewers, colleagues out there interested on this, I think you can always try and then get from your own experience. So us, it's partially out of convenience, so we don't need to running back and forth with incubator, because the culture incubator and ion optic setup is quite distance apart. And so, and we find that, it's basically, if a nut broke, you don't fix it, right? So
right.
usually when we do that, you have a dish right next to you. But again, I agree with you, we can use in other temperature, because typically if they have a next batch, or maybe already in the culture, they will take it out when they keep in 37 degree. But one thing we never do is actually put it on ice, because we just try to not to predict too much temperature changes, because you're going to perfuse them in the 37 degree. So we just thought to keep on room temperature and it work. So we did not do that. But again, going to the 0 degree, you may actually slow down the metabolism or shut down. That may actually maintain the cell better when you perfuse 37 degree buffer to wake them up. Again, try and error, and you learn from your own mistake, I guess, or experience.